So now let's talk about how Lambda functions work when you deploy them in a VPC. So by default, when you deploy Lambda, it's deployed in the cloud of AWS. And so you get access to the public internet. You can access the public API of DynamoDB. But in case you have a private RDS database in your private VPC and private subnet, then it's not going to work. If you deploy a Lambda function in a VPC, then the Lambda function is going to be assigned a security group. It's going to be deployed within your VPC. And so access to a private RDS database is going to work. But then once you want to access the public internet, you may get into some problems. So if the Lambda function is deployed in a private subnet, what you can do is that you can deploy a NAT gateway, for example, or a NAT instance in a public subnet, and so which is going to redirect traffic to an internet gateway onto the public internet. And the same way, if you want to access DynamoDB, which is a public API, first of all, you can access it through the NAT gateway, through the internet gateway to DynamoDB, or you could create, if you wanted to keep all traffic internal, a VPC endpoint for DynamoDB and have the Lambda function reach out to the endpoint directly. Note that if you deploy a Lambda function in a public subnet, it will not have internet access. This does not work. The only way for it to get internet access is to deploy in a private subnet and to use a NAT device. Now, even if you deploy it in a private subnet without a NAT, an internet gateway, the CloudWatch log feature of Lambda will work. Okay, this is something embedded in the service itself. So now that we know how Lambda and the VPC works, let's discuss how it goes for the IP. So when you deploy a Lambda function in your public cloud on AWS without a VPC setting, then it's going to get a random public IP from the AWS public IP. And so when it accesses the internet, the API that you're trying to access just sees traffic from a random public IP. And this is good. But say you control the API and you want to actually filter and you want to have tight network security and you want to guarantee that you have a fixed IP that reaches it or a set of fixed IPs. So the way we do it is that we deploy a Lambda function in our private subnet, which is going to talk to a NAT gateway, which is going to talk to an internet gateway, and then to our API on the internet. So you may say, well, this is the same, no? Well, it's actually a little bit different because when you deploy a NAT gateway, you attach a fixed elastic IP to it. And so therefore, any traffic coming through the NAT gateway onto the internet is going to be seen from that fixed elastic IP. And so effectively, all the Lambda function traffic will be seen from the same elastic IP. And with this architecture, we've given our Lambda function a fixed IP when accessing APIs on the internet. And therefore, we can use some kind of network security on the API end on the public side. Now let's talk about synchronous invocations of Lambda. So anytime Lambda is invoked from the CLI, the SDK, or API gateway, it's going to be a synchronous invocation. That means that the results is returned right away, or we wait until the results are happening. And any kind of error handling must happen client-side. For example, retries, exponential backups, etc., etc. So in this example, we have the SDK, and it's going to invoke our Lambda function, and then the Lambda function will do something. And then we'll get a response. And if we have a look at this architecture right here, the client is going to invoke the API gateway, which is going to proxy the request to Lambda, which is going to return a response, and then the response back to the client. In the asynchronous invocations, we have SNS, we have S3, we have Amazon Event Bridge, and Lambda will be evoked asynchronously. And in case there is an error on the Lambda side, there will be retries on errors, so up to 3 total. And so therefore, the Lambda function can be run multiple times, and so you need to make sure that in case it runs multiple times, the processing is the same, and therefore it's called idempotency. So for example, if we take Amazon S3, there's a new file event, which is an asynchronous invocation on Lambda, and it can do retries. And when these retries fail, you can define a dead letter queue, DLQ, that could be SNS or SQS for processing the failed events. So we've seen asynchronous and synchronous invocations. Now let's discuss 2 architectures for Lambda that's for something that looks seemingly similar, but has actually some big trade-offs. So let's say we upload files in Amazon S3, and we want the S3 to trigger a notification in Amazon SNS, and we hook a Lambda function to Amazon SNS. And alternatively, we do Amazon S3, we trigger Amazon SNS, but this time we send the messages into SQS, and SQS is going to be consumed by a Lambda function. So they look like the same. Lambda is going to be invoked whenever an image input is put in Amazon S3. But which one do you think starts immediately? Is it the first one or the second one? Imagine you upload 1,000 files a second, something like this. Well, with Amazon S3 and SNS, it's going to start immediately because, well, Amazon S3 will trigger a notification in Amazon SNS, which will immediately invoke a Lambda function. And you can go very high on the concurrency level if you have a lot of notifications in SNS. So therefore, for every image in Amazon S3, Lambda is going to be triggered as fast as possible, and you're going to get a lot of parallel executions. Now, if some of these do not go well, you may lose some data. You need to use a DLQ to make sure the failed Lambda attempts do end up somewhere. Now, if you are using the second architecture, then the messages go from Amazon S3 into SNS into an SQS queue. So this happens as fast as possible, and the SQS queue will fill up. But then Lambda functions will obviously scale as well, but they will consume a batch of messages and process them one by one. And so one Lambda function will have 10 messages, for example, and the second one will also have 10. And so the queue will not empty as fast as possible. So you're going to get batch execution. It's going to be a bit more efficient, but there's going to be a bit of delay from when the file is uploaded onto Amazon S3 and processed by a Lambda function. But in case you have Lambda function failures, well, the messages are going to be kept in Amazon SQS. Okay, so that's it for the second part of Lambda. I hope you liked it, and I will see you in the next lecture.